Good morning, students. Last time we have completed physical properties of aldehydes, ketones and carboxylic acid. Now we are going to start the chemical properties of aldehydes and ketones. Now in which first property we are going to see laboratory test for aldehydes and ketones. Now here aldehydes possesses hydrogen atom directly attached to the carbonyl carbon atom, and thus aldehydes easily undergo oxidation to carboxylic acid, and thus these aldehydes acts as a good reducing agent. But in case of ketones, this hydrogen atom which is directly attached to carbonyl carbon is absent, and thus ketones does not easily undergo oxidation, and from this we can differentiate aldehydes and ketones. The chemical properties of aldehydes and ketones are nearly similar, but these laboratory tests which are given by aldehydes, ketones does not give this reaction, that is aldehyde acts as a reducing agent while ketones does not act as a reducing agent. Now we are going to see first reaction, Schiff's test. That is, these are the reactions given by only aldehydes. Ketones does not give these reactions. First reaction is Schiff's test. Now first we must know what is meant by Schiff's reagent. Now Schiff's reagent is nothing but the solution of para-rose aniline hydrochloride. Color of para-rose aniline hydrochloride is magenta, but when sulfur dioxide gas is passed through this para-rose aniline hydrochloride solution, then it becomes colorless. This solution is known as Schiff's solution or Schiff's reagent. Look here, Schiff's reagent. It is a colorless solution obtained by passing sulfur dioxide gas through magenta color solution of para-rose aniline hydrochloride. Now we are going to see the reaction. Now here in aldehyde there is presence of hydrogen atom which is directly attached to the carbonyl carbon, and when this aldehyde is treated with few drops of Schiff's reagent, then this magenta color is reappeared. That is, the solution becomes red, pink or magenta color. Now this confirms that there is presence of aldehyde or CHO group in the molecule. This reaction is not given by ketones since there is absence of hydrogen atom directly bonded to carbonyl carbon. Second laboratory test for aldehyde is Tollens test or silver mirror test. Now first we are going to see what is meant by Tollens reagent. Now Tollens reagent is a mixture of silver nitrate and dilute NaOH, or when few drops of AgNO3, that is silver nitrate, is dissolved in few mL of dilute NaOH, then we will get brown precipitate, and this brown precipitate is then dissolved in ammonium hydroxide, that is NH4OH, and this solution obtained is called as Tollens reagent. That is, Tollens reagent is ammonical silver nitrate solution. Tollens reagent is nothing but ammonical silver nitrate solution. Now we are going to see what is the reaction. Now here, when aldehyde is treated with Tollens reagent. Now Tollens reagent is nothing but ammonical silver nitrate solution. That is, when we dissolve AgNO3 in NaOH and then NH4OH, we will get this solution, Tollens reagent. That is twice NH3 2 times plus and 3 OH minus sign. This is the Tollens reagent. When this mixture is boiled or heated or warm, then this aldehyde undergo oxidation to give RCOO minus, that is carboxylate ion, and this Tollens reagent undergo reduction. That is, Tollens reagent means silver Ag plus ion undergo reduction to give free silver. having oxidation state 0. That is, in Tollens reagent, the oxidation state of silver is +1. But when it undergo reaction with aldehyde, then here reduction of this silver is carried out to form free silver atom. That is, oxidation state of Ag is here 0. And plus for ammonia are formed plus 2 molecules of H2O. Ammonia is in gaseous state. Now here, when we carry out this reaction or this test in a test tube, this free silver obtained is collected at the edges of this test tube, and thus we get silver mirror. Therefore, it is called as silver mirror test. Due to absence of hydrogen atom directly attached to carbonyl carbon of ketones, ketones does not give any reaction with Tollens reagent. Third laboratory test for aldehydes is Fehling's test. Now here, first we are going to see what is meant by Fehling's reagent. Now Fehling's reagent is a mixture of or solution of Fehling solution A and Fehling solution B. Now first we are going to see what is meant by Fehling solution A. Fehling solution A is crystals of copper sulfate dissolved in H2SO4. That is, when crystals of copper sulfate are dissolved in H2SO4, then we will get Fehling solution A. And then Fehling solution B is the solution of sodium potassium tartarate in NaOH solution. That is, when sodium potassium tartarate is dissolved in NaOH solution, then it is called as Fehling solution B. Now here, when aldehyde is boiled with this Fehling solution, now this is the Fehling solution, that is, Fehling solution possesses Cu2 plus ion, 2 Cu2 plus ion plus 4 OH minus ion. This is Fehling solution. Now when this aldehyde is boiled with this Fehling solution, then this aldehyde undergoes oxidation. Aldehyde undergo oxidation to give carboxylate ion, and this copper undergo reduction. Now this copper is Cu2 plus ion, that is, here oxidation state of copper is 2 plus. But when it heated with this aldehyde, it undergo reduction to give cuprous oxide, red precipitate of cuprous oxide. And in this cuprous oxide, the oxidation state of this copper is Cu plus, that is +1 oxidation state. Now we know that the oxidation state of oxygen is -2. Therefore, oxidation state of copper becomes +1. That is, there are 2 Cu, therefore it becomes +1. Therefore, here this Cu2 plus ion undergo reduction into Cu plus ion, that is Cu2O, that is red precipitate of cuprous oxide is obtained. The ketones which do not possess hydrogen atom attached to carbonyl carbon, therefore they does not undergo this reaction, or they does not reduces the Fehling solution. But the ketones which contains alpha hydroxy group, that is alpha hydroxy ketones, gives this test positive. Next reaction we are going to see is laboratory test for ketones. Now here, when ketones are treated with freshly prepared sodium nitroprusside solution and then few drops of NaOH are added, then red coloration is obtained. Now here, this indicates that there is presence of ketonic group. Now reaction is as follows. Now this is acetone. This is the example. When acetone is treated with NaOH, that is alkaline solution, then formation of carbon ion takes place. Now here, this OH minus ion from NaOH absorb this hydrogen atom from ketone, and then this electron pair gets shifted on this carbon atom. That is, this H plus ion combined with OH to form H2O, and here formation of negative charge takes place. That is, carbon atom is negatively charged. That is, this ketone possesses carb anion, that is negatively charged carbon atom. And this negatively charged carb anion, when it is treated with freshly prepared solution of sodium nitroprusside, molecular formula or sodium nitroprusside is a complex compound or it is anionic complex. When this FeCN5NO2-, that is sodium nitroprusside, when it is treated with this ketonic carb anion, then here formation of this complex takes place, that is FeCN5NO CH3 C double bond O CH2 3 minus. The color of this complex is red coloration. From this we can say that there is presence of ketonic group.